Good evening. Tonight we're going to look at the data submitted by teachers and students from the 2016 Institute. First of all, I want to thank teachers and students, not only of 2016 but 2017, for the work you're doing, and some of you are continuing to work with us. Our evaluation of UT's Mission Earth data from teachers and students was very well received by NASA. And they suggested that the other programs actually follow our example of survey participation and analysis. You are also the data collection stars and data entry on the Globe website. These were two of the things that were most important to NASA, and so it put us in a very good light. NASA was very pleased with our results of the statistical analysis of the spatial abilities test and also the hydrology test results. Both of these tests showed statistical improvement from pre to post-test. The science attitude survey showed movement towards more positive attitudes of science and technology of our students. In surveys that didn't have definite correct answers, each question was analyzed individually. Are there ways we can improve? We always can improve. There are a number of ways that really will help us. We lost considerable data because the students were not consistent when they entered their student IDs. Some used their name in one test and their student numerical ID in the post-test. Please emphasize the importance of being consistent when using student numerical ID. The more data we have, the stronger the results of the analysis will be. We actually did not have enough data from the atmosphere test to run an SPSS analysis of the data. So it's really, really important that we have as many people participating in our surveys as possible. Next, please be sure that your students understand the importance of the surveys and tests. If they just hurry through the tests and don't think about their answers, it can skew the results. And I think if you share with them how pleased NASA was with their participation, they might be able to take it a little more seriously. Our data was analyzed in two different methods. The tests where there was a definite correct answer, individual tests were corrected and the data was entered into SPSS. Originally, this package, which was devised in 1968, it was for primarily social studies. Since that time, the program now is used by many sciences. In surveys where there's not a specific correct answer, such as the science attitudes test, each question was analyzed individually by comparing pre-test and post-test answers of each student. These then were graphed, and you'll see some of those in a bit. The hydrology data was analyzed by SPS by a paired samples t-test. Don't worry about wondering what these tests are. A paired sample t-test is simply used for things that have a pre and a post-test. It's also used for other things, but it's primarily a good test for pre and post. Here it is used to analyze the hydrology pre-test and post-test. The results of the analysis are in the next few slides. All right, this is the paired sample statistics. In this case, they're not really doing any analysis work. What they're giving us is the things that we're going to use in the SPSS program to derive these from. This part of the results gives us the basic data to find whether the difference between the two tests is correlated and significant. And the information that we need for those are the mean and the the mean of the pre and post test, the number of tests, which is represented by N, and the standard deviation and standard error mean. Again, don't worry about specifically those numbers. Those are just what SPSS uses to get the answers we need. I have done these back in when we were required to do it all and show all our work, which included pages of numerical problems. And it was a lot of equations and a lot of time. So SPSS is really good in that you're not finding as many errors in your analysis. All right, this first real analysis shows correlation. And the results of our correlation, and the correlation coefficient is R, is 0.572 between the pre-test and post-test. And that is a significant difference of rho less than 0.001. As you notice from this slide, we have a 0.000. And what that simply means is that the correlation is highly significant between the pre-test and post-test. The positive sign just simply means that it is in the positive direction if I would graph this data. In this final analysis, we really get some more information that was based on the statistics that I showed in the first thing, which was the basic statistics. The mean on the pre-test was 18.49. Now, you might wonder, well, there were only so many questions. How do I end up with 0.49, etc.? Remember the mean, what it is. It's the average of the number of test data we had. The standard deviation was 7.57. And the mean of the post-test was 28.17 with a standard deviation of 11.45. If you notice at the end, it says sig two-tailed. The significance of this two-tailed, which is pre-test, post-test, is highly significant increase. Notice it again is 0.000, and that's compared to 0.001, which is considered highly significant. Again, it is so important that we have the kids take these surveys for us to be able to show the two major tests that we did in 2016 was hydrology and the spatial skills test. So to be able to show highly significant increases for both of these tests tells NASA we're doing something right. The spatial skill results we'll go through again. Again, the paired sample statistics is simply the mean, the number of tests. Notice the number of tests on the spatial skills was much higher than it was for the hydrology, which was 148. The information here is the same as it was for the hydrology. We're looking at the mean, the number of tests, the standard deviation for pre and post, and the standard error mean. That was one that, excuse me, I have to go back. Finger hit that too fast. The standard deviation or standard error mean is something that is simply the standard deviation divided by the square root of the number of the test. The number of the test is 149. You will see in the next slide, we now have, I'm sorry, I went the wrong way. Uh, the number DF, that's the degrees of freedom, and simply the number of tests minus 1. In this case, you may wonder why we've got negative numbers. When we look at the pre-test and the post-test, that simply is telling us that the post-test was higher than the pre-test. Okay, again, look at the end. Oh, I went all the way back to the hydrology. Well, I'm sorry, screwing this up. Do you want to go back so we can record again?
I think you're doing fine, Mike.
Okay.
Yeah.
All right, sorry.
It's okay.
We covered that one. Okay. Okay. You notice again that our significance is 0.000, which means it is a highly significant increase in what the students learned about spatial skills. I think our program, because we have the kids use the skills, it really makes a difference when they take the test. All right, what about analysis surveys without specific correct answers? Those are the things like science attitude tests, where you're asking a student what they think about something. Not necessarily, there's not any correct answer. Since this had multiple options, if you remember there were 5, it took a large amount of time to compare the results for individual students and then to do this for the schools involved. The following graphs are samples of this type of analysis. The trends were very positive in all 41 questions. The question itself was, I would rather find out why something happens by doing an experiment than being told how it works. And you can see here, there were 695 answers to this particular question, with 225 agreeing and 290 strongly agreeing. So the positive of this particular graph showed a number of increases from 225 to 290, which gave us a total of 515 out of the 695 students that answered positively to this question. Another question was, science is man's worst enemy. Out of this, there were 668 answers. 277 strongly disagreed and 178 disagreed, which meant 455 out of 668 disagreed that science is man's worst enemy. Now, you may notice that that number of questions is different on this particular question than on the previous one. And you might say, well, they're taking the same survey. Why do you end up with different numbers of answers on a particular question? And that's simply because the student didn't answer the question. He just went on, and maybe he wasn't sure how he felt about it, so he just didn't answer the question. Some comments about the graph. Since we did not want tonight's chat to run so long that your eyes glazed over, I decided to only include 2 samples of this type of analysis. There were 41 graphs, 1 for each question. If you really are dying to see the other graphs, just send me an email. The disparity, again, between the number of answers given for different questions is that they simply didn't answer that particular question. A short analysis of our program. The actual report was 140 pages long that was used to evaluate our part of Mission Earth. Yearly report showed the following. Analysis shows our program is effective in engaging teachers and students in the GLOBE program and using NASA assets. Students are actively involved in collecting data and using GLOBE protocols, and guess what? Entering their data. It's not enough to just collect data. They have to enter it. And we were good with that. 100 students presented 80 research projects at the Satellite Research Conference. 25 students presented research at the Midwest Regional Conference. And 2 presented at the International Conference, with 6 participating in the International Video Research Conference. That's a lot of research done by our students. We should be very proud. Some final notes. If anyone is interested in a deeper understanding of the terms used in SPSS, excuse me, I've included a glossary of the terms on the next 3 slides. The mean is the average difference between 2 variables. And as I mentioned before, is the number of tests. Standard deviation, it is the measure of the dispersion of a set of data from the mean. Standard mean error, sometimes that's put down as standard error mean. For some reason, they put it different ways. It's simply the standard deviation divided by the square root of the sample size. And that's used in computing both the test statistic T and the upper and lower bounds of the confidence level. All of this involves a lot of equations. That's why I'm saying the way SPSS is set up, if the main thing you're looking for is the correlation and the significance. And that's what we spend time on. The correlation measures the strength and direction of linear relationships, graphs between pairs of tests in a positive or negative direction. This is expressed by the coefficient R, which ranges from less than or equal to -1 to R being greater than or equal to +1. And it's usually a 3-number point and then 3 numbers is what you will see in the correlation. Significance, which is rho, is the likelihood that a relationship between 2 or more variables is caused by something other than random chance. In other words, if we have 0.000, there's absolutely no possibility that it's a random chance. If value is less than 0.005, the results are significant. If it's less than 0.001, which R's are, they are highly significant. The 95% confidence level. This is one that throws a lot of people. What it's simply saying is, when you have a 95% confidence level, is saying if you take a poll or survey were repeated over and over again, the results would match the results we got 95% of the time. T is the ratio of the departure of the estimated value of a parameter from its hypothesized value to its standard value, or standard error. This involves, again, one of those ones that was lots of equations to get there. The DF is degrees of freedom, and all that is simply a number of tests minus 1. So we had 149 tests minus 1, 148. And finally, these are some references you can look at on the sample T test and also the Pearson correlation. Any questions? Or if you have any questions and you want to email them to me, I'll be happy to help you out. Have a good evening.